Anna Glowinski on TRE in the afternoon.
Now, for any of you sci-fi fans, you maybe imagined at some point in your life what it would be like to watch a double sunset on Tatooine, or maybe even stand on the sand dunes of Arrakis. But what's the reality of that? How possible, how likely is it that planets are out there like that? And how possible is it that we could actually land on them? Well, in the book Amazing Worlds of Science Fiction and Science Fact, Keith Cooper is exploring this exact question, the reality versus fiction. And he delves into it, seeing how realistic it is based on our current scientific understanding and also astronomical observations. And actually, some of the things out there in space are maybe even a little bit weirder than what people, the fictionalists, were first imagining. But anyway, we've got Keith with us right now. Good afternoon. How are you doing?
Good afternoon. Thank you for having me on.
I see that your name is Star Ranger there on your little name tag.
Oh, yes.
Is this because you're just a massive sci-fi fan? Do you live in this fantasy world of going through space, traveling through the solar systems?
Well, it's a little bit my job as a science journalist. I write about space, have been writing about space for about 20 years. So in a way, I do tend to live in space. Never been there, but it's ever since I was a very small child, space and science fiction has always held a fascination for me.
And how did you get into it? How did you turn that into a career, that passion?
Well, I wanted to be a professional astronomer. When I was 8 years old, everybody else wants to be a footballer or a fighter jet pilot or whatever. And I suppose I did go through those phases. But ever since I was very young, I imagined myself being a professional astronomer. And I studied for it and wasn't quite smart enough to become a professional astronomer and handle all the maths and everything. So I thought the next best thing is to write about the discoveries that the smart people make. So I've just tried to make a living out of everybody else's discovery.
Okay, that's really interesting. So you actually understand it better through words rather than through numbers. I think people's brains work in different ways, don't they?
Yeah.
Well, we need people like you because it's a topic that I'm also fascinated in. My brother actually studied astrophysics at uni.
Oh, really?
He was far cleverer than me. And I always wanted him to sort of translate into layman's terms what he was studying because it makes for great dinner-side conversation, black holes and traveling at the speed of light and big balls of gas, all the way down to the Big Bang Theory. But trying to make sense of that to somebody who's not studying it, who can't get their head around the numbers, that's actually a really fantastic skill that you've developed, and it's a really great thing that you're giving to the rest of us. How much studying is involved in what you do, and how much are you trying to explain to other people, in all of your work, not just in this book, the discoveries that are going on in space in ways that normal people can understand, or are you more talking to your peers generally?
Sure. I mean, my job is really taking sort of all the technical aspects of the research that astronomers do and trying, as you say, turn it into something that a layperson can understand. And just going back there, when I was at university and the lecturers were talking and it was all maths and very abstract, and I just wanted them to say, what does it mean? So I kind of took it upon myself to try and figure out what it means. And I guess that's where that has come from. So I do understand large parts of the technical side, and I'm able to translate that for the layperson is something that I really enjoy doing. And exoplanet research, so looking for planets that don't orbit our sun, they orbit other stars, other suns.
Right.
And when we look up at the night sky and we see all those stars, statistically, we expect every star to have a planet. And that's, the first exoplanet was discovered in the 1990s. So fairly recently, and it has just exploded since then. We've found thousands of planets, and billions of euros and pounds and dollars are spent on, building space missions to hunt for these planets, and giant telescopes on the ground in Chile, even in Spain, to look for them as well. So it's a huge industry in a way, and there's so many exciting things going on, and I mentioned there, the first exoplanet was discovered in the 1990s. Well, science fiction was talking about exoplanets decades before that, before we even knew there were exoplanets out there, and all science fiction writers had to go on was their imagination. So I was interested to see how well, the fictional planets matched the real planets that we're discovering. And as it turns out, some of the real planets are, as you mentioned, are really bizarre, stranger than anything science fiction had. But a lot of planets, for example, Arrakis from Dune, your listeners may have seen the two Dune films at the cinema recently. Actually, that was really well thought out in the original novel by Frank Herbert from 1965. Studies have shown that, there's probably quite a lot of planets out there that are arid, don't have water, but could still be habitable. Scientists have actually modeled it to see if it's possible. Wow. On the flip side, scientists also suspect there could be planets that are just completely covered with water, with oceans, thousands of kilometers deep, perhaps. There's just all these amazing exoplanets out there, and science fiction, where science fiction was sort of leading the field in imagining what these worlds were like before astronomers had discovered them. Now it's trying to keep up with the wave of new discoveries.
Wow, so it's almost flipped on its head. So people were just having to use their imaginations before, whereas now they're actually getting actual information and thinking, well, how can I create a story around this? And how, you've just given one example there. Could you give us some more examples of imaginary planets before we had all this access to finding out about the exoplanets, where people just relied on their imaginations? How many of those have turned out to be, to correlate to something that actually is in existence, first and foremost?
Yeah. Okay, so in Star Wars, there's Tatooine, homeworld of Luke Skywalker, and that orbited two suns. And it's interesting. We've discovered quite a lot of planets that are in solar systems with two suns, but they don't orbit the two suns. They kind of orbit one sun, and then there's another sun off to the side, whereas Tatooine orbited both, so you get the double sunsets. And that's quite rare, it turns out. We don't fully understand why. Because
sorry to interrupt you there, could it in theory be possible, scientifically?
Oh, yes. Yeah. The theory suggests that it is possible. And astronomers are looking for them, and they're a little bit surprised that we haven't discovered as many, because double stars are really common in the universe. It's not uncommon to have two stars together. Okay. So why we don't find so many planets orbiting both of them, like Tatooine orbited its two suns, isn't clear. Another planet that I quite like is from a novel by Ursula K. Le Guin, came out in 1969, called The Left Hand of Darkness. On this planet, it was there's a strip around the equator where it was cold, but you could survive there. And the rest of the planet was just ice, all the way up from the mid-latitudes, all the way up to the poles, north and south. And the reason I find it interesting is because Earth had its own phases in the past, hundreds of millions of years ago, when our planet was almost completely covered in ice. So that's an example of a science fiction world that mirrors a little bit what Earth used to be like, and what presumably other planets could be like as well. So we're kind of learning about our own planet in the process. And that was a really well thought out world by Le Guin. And there've been so many others. There was, in Star Wars again, we had Endor, which was where the Ewoks lived in Return of the Jedi, and that was a moon. And again, moons, we would expect there be lots of moons around exoplanets, but we aren't finding many at the moment. Yeah. Mostly because they are difficult to discover. In the next 10 or 20 years, we might find more of these moons like Endor and like Pandora from Avatar. Yeah,
which was a lot more fertile. It was a land that showed a much more opportunity to actually be able to be lived on. But I wanted to ask you that same question, but from the other point of view then. So now science is discovering planets which are pretty mental, which people with imagination hadn't invented yet. What sort of things are we seeing that we haven't actually seen in books and in films?
Okay, well, let's put it into context. Let's look at our solar system first. Uh-huh. So we have the small rocky planets closest to the sun, Mercury, Venus, Earth, and Mars. And then we have the big gas giants like Jupiter, Saturn, Uranus, and Neptune further out where it's cold. And that's what astronomers expected to find, that the little rocky planets would be closer to the sun, where it would be warm and there could be life, and then the big planets further out. The very first planet we found was huge. It was bigger than Jupiter, and it was really close to its star, like just 1 million or 2 million kilometers away, which sounds like a big distance.
Next door.
For planets, that's really, really close. And they started finding all these planets like this, and astronomers were really puzzled because they couldn't figure out how planets could form so close to their star. And obviously these planets get hot in excess of 1,000 degrees Celsius. So that led to the theory of planets migrating. So they do form further out, and then sometimes they kind of wander. Well, rampage is a better description. They rampage their way in closer to their star and kick all the other planets out of the way. And that's how they end up there. And then that
like an epic game of ball, like French.
Yeah, exactly. And that came back onto theories of how our own solar system formed. And it turned out that maybe Jupiter also migrated in a little bit, and Saturn kind of caught hold of it and pulled it back with its gravity. But that might have affected how Mars grew and possibly how Earth grew as well. So we were learning about our own solar system and the birth of our own planets from studying these surprising new planets that we found around other stars.
And how do we find them? Okay,
so there's two main ways. And the first one is we look for stars that wobble. So you imagine a planet orbiting a star, and it's the gravity of the planet is acting on the star and just causing the star to wobble very slightly around its center of its axis. And we can detect that wobble in the Doppler shift of the light, and we can detect wobbles as small as 1 meter per second. So these are very, very small wobbles. Another way is when a planet moves in front of its star. From our point of view, and as it moves in front, you can imagine it blocks some of the star's light and it creates a dip in light. The dip in light is less than 1%, but we have sensitive instruments that are able to detect that dip. And if we see that dip 3 or 4 times in a row in regular periodicity, we can infer that, there's a planet there orbiting with a period of so many days or years. We have directly photographed a few planets. Not many. They tend to be very big, recently formed, so they're still warm. That helps them glow in infrared light, and they're far from their star. And they just appear as little pinpricks of light. Sometimes you see these artist impressions of worlds and clouds and continents and things. Our telescopes aren't powerful enough to be able to take a picture of a planet like that.
Right.
So I guess when you have these artist impressions that accompany these press releases describing these discoveries of Earth-like planets, and I say that in quote marks because we don't really know if they're Earth-like. I guess that is science fiction in a way. That's the artist using their imagination a little bit, coupled with an educated guess as to what the planet would be like based on its mass and its size and its distance from its star.
And what's your feeling? Do you think that we're going to start developing the technology to be able to get better and better photos and really start seeing?
Definitely.
And then will we be able to start visiting these planets? Do you believe that? Will it be possible?
That would be a big step. Well, in terms of photographing them, Europe is building the extremely large telescope. They literally call it that, the Extremely Large Telescope. It's a 39 metre
I love
diameter.
A name when it just does what it says on the tin.
Well, it's a successor to the Very Large Telescope, so I don't know what they're going to call the next one after the Extremely Large Telescope. It's a giant telescope. It's in Chile at the European Southern Observatory. That has the clearest skies in the world. It's a 39 metre telescope. That should be able to start imaging planets closer to the star. Possibly in what we call the habitable zone, which is the distance from a star where temperatures should be right for liquid water to exist on the surface. And as we know, liquid water is crucial for life as we know it. And then in the 2040s, we should hopefully see a new space telescope go up. It doesn't have a name yet, but the plan is it's a NASA sort of led project, but I imagine Europe and other countries would have some involvement as well. And that would be specifically designed to start taking pictures of planets. We still might not be able to resolve continents and things, but we would definitely be able to see, a point of light that would be maybe an Earth-like planet around a faraway star. And we can learn so much just from that point of light. We can break it down into its respective wavelengths and see what molecules are in its atmosphere and whether there's water there and oxygen and things like that. In terms of visiting, not anytime soon. I wouldn't rule out maybe some kind of robotic mission that could maybe get to the closest star system, Alpha Centauri, in about 40 or 50 years. So possibly by the end of the century, we might be in a position to get a mission that could go there. But in terms of sending people, that's a long, long way off. I mean, we struggle to get people to the moon at the moment. So I think, traveling many light years is not something we can do at the moment. No. Unfortunately, and that's where science fiction comes in, because science fiction is able to transport us to these worlds, in the pages of a novel or on the cinema screen or on TV or in a computer game. And we can, as more and more exoplanets are being discovered and the science gets better, that feeds back into the fiction. And that helps to portray to the public what these worlds are possibly like.
Yeah, and I guess it's, from an author's point of view or from a writer's point of view, they're having to read the science, and in order to be credible in their works of imagination, they kind of have to justify the whys behind it. Because I've always even thought that with like Harry Potter, there's no pretense that it's a scientific book. He's doing magic, which doesn't exist. But what I always thought J.K. Rowling did really well was somehow justify. She used a method to justify how or why that magic would work within like the parameters of the rules that she set. And so I guess that's the work of the best science fiction authors, is to use the science to create their narratives so that they don't just sound utterly ridiculous.
Yeah, I mean, I spoke to several science fiction authors when writing my book, and I asked that question: is scientific accuracy important to them? And they said yes, to a point.
Okay,
but they don't let it get in the way of telling their story. If they need something to happen, and it's not wholly scientifically possible, they'll gloss over it so they can tell their story. I mean, they are right that science fiction, it isn't part of the school curriculum. It's a form of entertainment, so they shouldn't be beholden to getting the science right. But a lot of them, will try. A lot of them understand science very well and try and sprinkle as much science as possible into their stories. But as you said in Harry Potter, as long as it's consistent, then the story holds up.
Yeah, I really like that answer. And I'm so glad that you asked that question in your book and you spoke to people about it. That's super cool. And then I guess the obvious question that people might be interested in is, do you touch in, the possibilities of other life forms? What is the reality of us actually finding alien life forms in our lifetime? Do you believe that they are out there? What does the science community say?
It could happen tomorrow. We could detect a radio signal from another world through SETI, the Search for Extraterrestrial Intelligence. That could happen tomorrow. And we're also looking for things called biosignatures, which are gases, as I say, like oxygen, methane, carbon dioxide, water molecules, things like that in the atmospheres of these planets, that would be big clues that there's life there. Do I think there's life? I don't know. I haven't seen any evidence either way to be able. I'm not confident to say yes or no at the moment. I'm very open-minded about it. We certainly shouldn't rule it out. We don't really understand how life began on Earth, so it's difficult to say whether we think it would be common in the universe or whether we're the only planet with life. I think it's 50-50 at the moment. But yeah, we keep looking, and fingers crossed, as I say, it could happen tomorrow.
Say fingers crossed. Well, we don't know. We don't even know that would be a good thing or a bad thing, but
true. That's a whole other debate. Yeah.
Yeah, but I guess that's why the stories are written. Look, it's been really, really fun talking to you. Can you just tell us a bit about the tone of your book? Is it light-hearted? Yeah. Does it go into small little stories? How is it sort of laid out?
Right. Okay. So I look at all the different types of planet that have been in science fiction. So desert worlds, like in Dune. Planets around two stars like Tatooine, habitable moons like Endor and Pandora. And then I sort of address how realistic they are, and then look at examples of real science and real planets that we're finding and how they compare. It's it's written with the layperson in mind. I hope that people who enjoy science fiction will learn some science from reading it, and people who enjoy science might think, oh, that science fiction sounds interesting. I'll try this novel. I'll try watching this film. So yeah, I hope it will be understandable to everybody. It's not technical, and I hope it's a good read.
Oh, it sounds really interesting. What a really novel idea of bringing those two worlds together. I think it sounds great. Star Ranger, or should I say Keith Cooper, thank you so much for joining us today. It's been a pleasure speaking to you.
Thank you very much. A pleasure. Thank you.